All right, I think that's good. A lot of static on the audio. Don't think there's anything I'm going to be able to do with that on stream, though. It is the input capture. Oh, there we go. Okay, I think that's fine. Let's do that. Oh, I shouldn't listen to myself. That's going to be super weird. All right. A little bit of a scuffed test of a morning stream here. Thinking about doing this a little bit more often. Today I'm going to do asteroids. So this game here, choose a ship. I'm really bad at shooting this ship. But yeah, flying the ship around, doing a couple things. We need a life system for this, and we need particles. I think particles might be today's order. I wanted to take a look at this month in Xylem first. Looks like there's a couple new crates that are interesting. Web demo of Velato. Velato is a parser and driver for Lottie animation files using Velo. That's very cool, actually. So this is Velo, I think the back-end renderer for Xylem, SVG renderer, if I remember correctly. Rendering Lottie files is what it sounds like, which is pretty cool. Lottie is this. Free lightweight animations, yeah. They have some, shop or whatever these days. But it's basically like After Effects to web animation without being super heavyweight, which is very cool. So it's like this thing on the right here, where it's like this little animation, probably created in After Effects, exported to like a JSON file, and then rendered on the web. So that's very cool. That's Velato. Wow, I caught a live stream. That's the first. This is the first live stream I've done in a long time, y'all. So it's a bit of a test. If you notice anything off, let me know. Gonna do some asteroids development today. And right now I'm just looking at this month in Xylem. Looks like there's a couple new crates. Velato for parsing and rendering Lottie files, which is very cool. Velo SVG. I think Bevy motion graphics. Bevy motion graphics uses Velo, but I don't know if they are using any of the newer crates. There's a Bevy Velo renderer that is very cool. That kind of integrates these technologies. But I haven't played around too much with Bevy motion graphics, so I'll do that at some point too. This is a parser and renderer for SVG, which is very cool. One of the things that I want to do is do some like dynamic open graph images. So being able to render and modify SVG would be very helpful for that. And then Android Trace, I think, is less interesting for me. Android NTK tracing, that's like the native SDK. Cool. Some like GPU frames and stuff like that. Swap chain, dispatching render. That looks like Vulkan queues. And then I saw this right before I went live, a Rust port of the ear cut polygon triangulation library. One of the Bevy projects is using this to cut windows in 3D scenes. So they do like a 2D window cut and then pull that out. It's like a Sims game. So all that's very cool. But today I think we're going to do Bevy Hanabi. And I have everything else dark mode, so maybe we'll switch back to dark mode. So Bevy Hanabi is a particle library for Bevy. And somebody mentioned on a video very recently, the Asteroids video this week, that they would love to see some particles. I haven't looked at the current release of Bevy Hanabi, so I'm not entirely sure what the API is these days. But we should be able to get some particles going. Are you planning to have the asteroids bounce off each other? I don't think so. I don't think that's the way it works in like regular asteroids, right? I think they just pass over each other. Yeah, so you can see overlapping on the right here. So I don't think they bounce off each other in the original Asteroids game. I kind of forked this. So I built this repo on the plane to London and back from London when I was giving the Rust Nation UK talk. And it was kind of just an experiment. So I'm taking it in two different directions. One direction is going to be like strictly asteroids. It's not going to look like this because I'm going to use sprites and stuff. And then the other direction I think is going to be more of like a maybe like a roguelite in space kind of thing. So for that, I can change up how it works. But for now, the asteroids are not going to be able to collide with each other because I don't think that's how it works in the original game, at least when I remember having played it in the past. So effect asset, that's roughly what I remember from Bevy Hanabi. Something like this would be cool. This is 3D, so we need a 2D version of it. Right? We don't need a 2D version of it, but you can see a bunch of these particle examples. This one might actually work for us to take a look at because it's spawning particles based on a transform. So it's like moving a transform around in a figure eight. And if we just spawn once, that would work for us rather than doing it in a loop. You can do a whole bunch of really cool stuff with Bevy Hanabi. You can do like force fields and particles that, you know, are impacted by external forces and things like that. White square mesh. Cool. This is multi-camera stuff, not necessary for our work. Only having particles in certain locations. Is there a one-shot burst of fixed count of particles? I think that's really what we want. Like this blue thing, I think is, no, it's center. So this, actually, you know what? The blue might be better. It's a continuous burst, but it fades out over time in a direction, which is kind of cool. And the asteroids are going to be moving in a specific direction. So I think we're going to look at this one. This is 3D still, though. Spawn on command. This is cool. I did something similar to this for a block breaker game. Burst of particles when an event occurs. That's really what we want, honestly. Because we already have a meteor destroyed event. So we can just fire the particles off whenever a meteor gets destroyed. Yada yada, visibility, random. This has gotten a lot bigger since the last time I looked at it. Lifetime modifications is very cool. So the longer a particle lives, you can kind of like modify the color over time. So that could be a cool effect to have, like as the meteor particles kind of fade out. Billboards. If you don't know what a billboard is, it's kind of like a 2D sprite in a 3D world. So this is like a sprite rendering as a bunch of particles. So yeah, let's do the spawn on command one. So that's not going to be 2D, so we're going to have to do a little bit of modification. I think we're going to have to also look at the 2D example here. But having examples is really one of the things that I love the most about the Rust ecosystem. Spawn on command. Let me get rid of all of these other. Okay, so we've got 2D. I believe we need vertex writable storage here. Yada yada. They've got the world inspector from Bevy, inspector eGUI. That's a very cool thing. I don't have that in Asteroids right now. Default plugins with the log plugin. Looks like they modify the render plugin settings. Synchronous pipeline compilation. I don't know what the default for that is. And then render creation is the WGPU settings, which is the vertex writable storage. And then setting the title on the window. So it's really just this render pipeline settings that we really need, and then the Hanabi plugin. Yeah, confirm the original had them overlap. Newer graphics versions seem to show shadows based on z-index to be like passing under each other. Interesting. That's very cool. We could get into that at some point. Thank you for looking that up. So we've got startup system, close on escape is a built-in Bevy system. If you're not aware of that, that's actually a very like kind of cool thing. So it's just this system that Bevy has built into the, not the prelude, but just built in. And if you hit escape, the window closes. So you don't have to code that yourself. Update plane. So setup is 2D projection, material mesh bundle, just a rectangle with a color gradient for particles. So gradient is coming from Bevy Hanabi, basically from one color to another. X per writer, interesting. Writer literal 0 X per. This whole writer thing is new to me. Is the writer thing documented in here? Because I think we're not pulling in anything. Yeah, it's just a Bevy Hanabi prelude. So we probably need features 2D. We haven't installed it yet, so that's fine. So the idea is create an effect asset. That's what I'm used to doing for Bevy Hanabi. This is color gradient. This module expression is something I haven't seen yet. Randomly initialized particle to be over the surface of a sphere of radius 2 units. So we've got these like modifiers for things like how long it's lived, position, etc., etc. In this case, it looks like it's using that literal syntax, so module.lit. It's a little awkward. Initialize a radial initial velocity to 6 units per second away from the same sphere center. Yep, cool. Total lifetime of the particle. This modifier is almost always required. That's important. Otherwise, the particles won't show. So we have to set a lifetime, which is going to be this lifetime attribute. In this case, they're adding gravity like acceleration downwards, so the particles are just falling. The effect asset is then created. Maximum number of particles alive at a time, I think, is the maximum number of particles for all of these instances. So you can kind of limit how much GPU power you're spending spawning little particles. Spawn 5 per second. So this is going to be like spawn once with name, initialize a couple of things, update. So not too bad. The syntax is going to be a little like trip over ourselves, but it'll be fine. And then it's got the color over lifetime modifier with that gradient. And then we just put that on the bundle. Cool. So back to our original example, there's going to be some kind of event that spawns here. So we're coming up with this gradient. We've got this expression writer thing with the lifetime that we need. This is required. Set the lifetime, circle modifier. We probably do want a circle, so that's fine. Velocity modifier, center axis speed. Finish writer. I want to look into this module writer a little bit off stream. So I'll probably do another Bevy Hanabi video. I have a couple of them on the channel. I haven't looked at it over the last couple months, and it looks like the API has changed to include this like module writer thing. So that's going to be important for the video. There's a constant round modifier, spawner rate, 30 particles per second. We don't really need per second. This was the one that spawns on an event, right? No. Setup and... No, this is just 2D. Okay. This is the spawn on event. So all the same stuff. And then update. Do we have an event reader? No, we don't. If collision... Spawn something out of translation, pick a random color, set the spawn color, set the collision normal, interesting. And then reset the particles. This isn't the most intuitive API, honestly. I feel like it got less intuitive since the last time I used it. It is meant to be like high performance GPU based particles, but the idea here being place the well, so we're querying for the effect that's associated with, you know, the ball or whatever, right? And if there's a collision, then we don't need this normal because this normal is based on the side of the wall. This is like a block breaker grid or a block breaker square. So it's trying to do like the normal off the wall, I think. So we won't need this. Spawn color, we probably don't need. And then it's just reset. So it's basically like when collision, set the transform, and then reset the particles. Which isn't too bad. There's quite a lot here for constructing these effects, though. We're going to have a fairly, you know, basic usage of it. So let's see. Cargo, add, Bevy, Hanabi, what, F? Was it 2D that we need? I guess everything is enabled by default, so it doesn't even matter. But we can disable most stuff. So Bevy Hanabi. Reset feels like an odd method choice to spawn particles. Yeah, I agree. Let's go read the docs for reset. So it's reset on the effect spawner is what it is. So this is the thing responsible for spawning the effect. Component is automatically added to the same entity as particle effect it's associated with during tick spawners. which is something that they run. We don't run that. So basically we create the particle effect, then this effect spawner is automatically added and kind of like clones our particle effect settings in. And then resets the spawner state. So this thing is stateful in some way. Not entirely sure why it's stateful yet. Presumably it's calculating like the limit of particles like we saw before. So this effect spawner is presumably responsible for making sure that there aren't too many particles on the screen. Yeah, here, particle spawn count. This corresponds to the number of particles that will be or have been spawned this frame. So yeah, I don't know. It's a little bit weird. I see that it's on effect spawner and not something else. It would be nice if it told us what this state was. So we've got the spawner, thing that actually does the spawning. Got the accumulated time since the last spawn. Time limit until next spawn. Number of particles to spawn. Okay, so this is probably tracking all of the long-term stuff. So we're not doing a repeated effect spawn. So a lot of this is going to seem like extraneous complexity. But it'll probably make more sense if we do something a little bit more complicated. If we spawn multiple particles over time, if we transition colors over the lifetime of the particles, if we want to modify them as they, you know, move across the screen or whatever, or have them like interact with things. That's my guess anyway. So let's try to get something to spawn. We need to create an effect first. Well, first we need to set everything up. Let's set everything up and then let's do that. So we've got Bevy Hanabi features. This is what default features. False, I believe, is the right thing to do there to turn everything else off. So we don't need 3D, we don't need the world inspector, and we don't need the GPU tests. And then I believe meteors is where the event happens, but this is where we need to set the render plugin stuff. We will need the Hanabi plugin in, but the WGPU settings are probably more important. So let's set up the WGPU settings at the top of our app. We will need to bring these into scope. So Bevy render settings, WGPU settings, probably same thing for WGPU features. I do kind of wish there was like a Bevy render prelude, but there's a lot of preludes already in Bevy, honestly. So we've got the render plugin set up off the default plugins. We do not set to handle that because render plugin is already included in the default plugins. So we're basically replacing it. WGPU settings to do the vertex writable storage. We need to add the Hanabi plugin as well. So I'll throw that in down here. I have this giant stack of plugins because that's kind of how I like to organize my applications, my Bevy applications anyway. See, this has a prelude, right? So prelude star. We probably don't need star here because we're only dealing with the Hanabi plugin. And then in meteors, we have the meteor destroyed event, or actually the event reader in that system. So like right here is where we're going to spawn our particles. We could probably do it after this match. I don't think it matters, though. So let's do it. We're probably going to create the same effect for everything. So let's create the effect outside of this loop. It doesn't really matter because the amount of meteors that get destroyed every kind of frame is going to be like 2, maybe 3 at max, like if you get something super lucky. So it's not like creating this effect is going to have a significant performance impact or anything like that. So this is going to be, see, they've got PBR bundles, which are 3D things. They're naming them, that's just fine. We don't have names on our stuff, which is kind of irrelevant, but they aren't inserting the particle bundle on this. Are they doing it on something later? Yes. So how does this target the right thing? Effects, add effect asset, spawn in our particle effect. Are we using the name? Spawn on command. Spawn color. I guess we don't associate it at all. Effect properties. Yeah, okay. So this is an effect without ball. What do we put ball on in this example? Wow, there's too many balls. So ball, name new ball, ball radius, material. Why would it have without ball? Because it never inserts the effect on the entity that has the ball component. So the ball has a velocity, it has a name, it has a PBR bundle. None of those are Bevy Hanabi. And it doesn't save the ID or anything, so we're not fetching it later and adding more stuff. It's interesting. Okay, well, we're querying for the effect for some reason without ball. I don't know why that is yet. Maybe because there's an effect spawner that's associated with ball. Did we add that to ball later? Spawner reset. I don't see us adding anything to ball. We just use the translation. So I'm not really sure why without ball is there. I think that might just be like an artifact. So we're going to need this query to get any of the effects. We're going to make sure that we actually have the effect available. This is an interesting comment. So the first frame where the effect spawns, effect spawner is spawned during post update. So it won't be available yet. So we've got like update, pre-update, and post-update, startup, pre-startup, post-startup. I don't know that those are the actual names now that I think about it, but basically the idea is like we've got startup, update, and then we've got like before and after startup and update. So it's saying that this runs in post-startup or post-update. So if our system runs an update, then the effect spawner doesn't run until post update, which is the same frame. This is running in the update schedule, right? Yeah, it's running in the update schedule. Okay, so it's basically saying that Bevy Hanabi is doing something in post update that matters. And it's possible that we won't be able to get the effect here. So this effect spawner in our query isn't going to exist until after we spawn I think that what that says to me is that the effect spawner should be spawned in like the startup. Or like asset loading is kind of what I'm thinking, right? So like we have, where are we? Here's our assets collection, right? So we're using Bevy Asset Loader. It's async, so we're adding a loading state. We have a game state here that has like asset loading and menu and playing the game. So inside of this asset loading, it feels like we do asset loading, then maybe we do effect spawning, and then we get into the game. Because otherwise we won't have the things available because of the order in which they are spawned in the schedule. It's interesting for sure. Let's go back and just continue with our messy version for now. So we do need to set up an effect. In the 2D example, they do some like gradients and stuff. So let's take the effect they have in the 2D example and use that basically verbatim. And then we'll trigger that using the logic we see in the other example. This is going to be a lot of code. I don't know exactly where to put this code yet, honestly. Like it's quite a bit to construct this effect. I don't think it takes anything from the environment, so we could just put this into a function. We do need effects. Effects is going to be that query that we had earlier. Right, so we need access to the resource database that contains the effects. And then effect asset is a prelude thing, so we'll go all the way back to the top. To use Bevy, Hanabi, prelude star. So we've got our event handler here with the event reader. It is now querying for the effect assets. Yeah, I do think that this is true. I think this should be somewhere in like startup or something like that. That's why they're doing this weird. Actually, is it in startup here? It is in setup for them. It's not in setup. It is in setup for them too. So let's do that. Let's move it out into setup, actually. So that's all of this code. And then this. Just made two cursors and selected two things. And then when I go to, we don't have anything running in startup in this plugin, do we? So let's do .add systems startup register effects or register meteor effect maybe. Hey Jacob. Yeah. Register meteor effect. And then because I had two cursors, I can just make two cursors, paste this in, and it goes all in the right places. So we've got the effects. This is some random effect. Why is round modifier? Where's round modifier coming from? I wonder if I'm working on something that is... Ah, there's the round modifier. I don't think that got released yet. I think I need to look for the current release, actually. Docs.rs, Bevy, Hanabi, 0.10. And in here, let's go for tags 0.10. So this is what we're going to go with instead. They have a new round modifier that is not in a current release, which is interesting. But we don't need it. So I'm going to take the code from the 0.10 version of this and plug it in here. So we've got register meteor effect. We're getting the effects assets database. This creates some gradients. This expr writer, which we haven't really dived into yet. We're also mostly using literals with this writer. So like 0, Z, 0.5. So I'm not sure this writer is actually giving us any like real benefit in this particular example. But as I said before, if we do something a little bit more complicated, it probably would. We need commands as well in this. So commands are how we mutate the Bevy world. Capital W world. And then I don't want to name this effect 2D. Let's name it effect meteor explosion. Okay. We still have something red here. Why do we have red? Because effect is here because we didn't remove this from before. Okay, so we've got our effect now. I think the 2D example is constant, right? Yeah, so it kind of like constantly goes out. We'll have to modify this later. We'll have to take a look at the on spawn. But for now, I think we're just going to kind of hack it together and see what happens. So in our meteor destroyed event, we don't have ball. I don't know why this is here, so I'm just going to comment it out so that I remember that it was there, just in case something weird does happen. This has to go. I've gotten into the habit in all of my Bevy apps of doing, anytime I need to do like an unwrap or an expect or something, because you can't return errors in systems, because there's nowhere to return an error to. The thing I've started doing is just warning and then returning from the system. And it makes refactoring much nicer, because if you change some of your systems, if you remove some resources or something, you'll get a warning and your game will keep running instead of your game panicking and crashing, which is actually harder to debug. So assuming we have everything we need, yada, yada, yada. I don't know why this is destructuring here. Oh, it's let else. Okay, that's fine. Transform, yada, yada. Hey, RT, how's it going? Thanks for coming to the stream. It's a bit of a test stream, so if you see anything that is kind of like off or whatever, let me know. I'm not necessarily going to fix it today, but I'll fix it for next time. Translation, collision. So we need to set the effect transform translation. And then we need to reset, I think is all we actually need to do. Does Bevy not have a concept of middleware to catch errors in systems? So the question is, what would you do with them if you had it? Right? Like, you have a system running somewhere, it does something, it catches some error. What do you do with it at that point? To me, basically what I'm looking at is like warn and return. So basically the same thing we're doing anyway. Effect transform. So meteor destroyed. Let's do it here for every meteor that gets destroyed. This is going to be destroyed at. That translation. Yeah, I don't really see the utility of middleware there, because we're already warning and returning, right? And I could see something along the lines of like implementing tracing to, collect errors and then return them like in a report or something. But realistically, somebody's going to be playing this game on their computer. They're not going to know anything about like how to debug it. Like, for example, if this effect wasn't there for some reason, right? That's what we're looking at here. If it wasn't spawned in the post update, what is a user that plays our game going to do about that? Really nothing. And what we don't want to happen is we don't want to panic, because that'll just crash the game, and that's a terrible user experience. So we do the warn. You won't get the warn unless you have the logging set up. So you could theoretically have like a tracing implementation that collects everything, but there is no like built-in middleware to just like return an error. There is built-in tracing, though, is worth mentioning. I'm not going to get into that now, but there is like warn and everything that comes directly from Bevy. Well, it's dependent on the platform, so it's tracing on desktop platforms, and I forget what it is in browsers. Okay, translation, spawner reset. My question is that enough? Because we set everything up, we set the position, it's running whenever that event happens. And then I would kind of expect this to, in the failure mode, like just spawn something that's kind of just runs forever. Okay, so that went wrong. So we've literally messed up our ability to spawn. So that goes away, but it's no longer spawning anything. So let me comment this out. I think what's probably happening here is that this query isn't landing. Because the despawn happens before this event gets fired. I need to get better at controlling my own ship. Yeah, I think it's going to be this query. So there's something about that query that is not good enough. Yada, yada, yada. So let's check that for validity. We'll run it again. Yeah, okay. So now our event system is running. The meteors are spawning again. So the issue is that this query is preventing this system from running entirely. So effect properties, effect spawner, transform. I'm returning? Yes, I am returning. Oh, you think that this is just constantly returning? Right, I didn't put my warn in there. That's why I didn't see that. Which is exactly what you were just talking about. Hilariously. Okay, so effect not ready yet. Returning. It's kind of hilarious that I was just talking about that and then ran face first into it immediately. So it's never ready, which is really interesting. When it doesn't have the effect spawner, yes, that is true. That is how they have it working here. Right? So it doesn't, like it spawns in the effect, which we are also doing, right? Up in our setup. Register meteor effect, yada, yada, yada. Spawn the particle effect bundle. We spawn our new effect with a Z layer, Z index issues. Great. And then all they're doing is querying for it. Right? So we've got update and setup. Those are the only two. All that happens in setup is it creates that particle effect bundle, and then immediately starts querying for this and has this at the very top. So maybe this has to spawn every frame. That would be weird. Properties spawner effect transform. Properties spawner effect transform. We don't really need properties because I don't think we have any on the current one. So let's get rid of that. Spawner effect transform. Hello, hello. Welcome to the stream. Thanks for stopping by. Okay, so that still runs. So it's the effect properties that was the issue. Let's take a look at this example here. Effect properties. Yeah, I would imagine that that check needs to be lower in the system as well, but in the example, they don't have it lower in the system, right? They have it right at the top. So there's something about like the effect properties, for example, that might be being configured in one example and not the other. Maybe the effects should be handled in its own system. Yeah, that's possible. Entirely possible. Right now, I'm just want to get it to work. Their system is just spawning the effect. That is not true, is it? No. Collision, true, zip, ball velocity. Because the ball is bouncing around the screen. So position here, collision false, normal, yada, 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 while, yeah. So they set the normal, they set the coordinate, they set the velocity coordinate, and then they set the collision. So this is the ball velocity, the ball normal. So they're doing more stuff in the system. They're not just doing an effect spawn. And they're doing the stuff that they're doing after. Oh, you know what the issue might be, though? We may not need this. Because we do have an event listener here. Right? So we're reading the event and we're doing the query. So it is possible that that might need to run all the time. I didn't think it would be. Okay, we do have this available to us now. Effect transform spawner. So this is going to be empty again, right? So this is now spawning new asteroids, but it's not creating particles. So is it important that this runs every single time? It only runs on collision. So no, that is not true. Wow, your compile times are quicker than mine. I do have a reasonably beefy computer. This is also an incremental compile. This is actually an incremental compile without even, like, I'm not doing the shared library stuff that they say is a good idea and whatnot. So it may just be a difference in computer, RT. I don't find my Bevy compiles to be that long. You just made Bevy with Asteroids with Bevy a week ago? Nice. How'd that go for you? Okay, effect transform, destroy that, right? We're not getting the warns, so it is running. This is picking a random particle color. Update plane. That's not what we need. Setup, expert writer. I bet you that there's something about effects add with name, init, etc. This is not relying on that name, is it? Is it relying on that name? It did name this effect 2D. Do we need that to match here? That would be really weird. We got meteor explosion here. Although that would be very, very strange. I would not expect that to be the reason that this is failing. Your asteroids works but can't reload level. Okay. I think a lot of first-time games are basically just like drop into the game directly and then close the app and restart it to get the game to run again. So let's take a look at this a little bit more closely. I think that the 2D example is trying to spawn something that just runs forever, right? So there's probably something in the setup of that is different than the setup of the other effect. So that would be all of this, for example. Here, the spawn on command and the effect are different names, so I don't think we actually need them to be the same. I'm going to take the example from spawn on command, even though it is a 3D example. There's a couple of things that I need to modify, like this ball radius and whatnot, but that's fine. Effect asset. Let's get to the 0.10 version of this in GitHub, because that was the 0.13 update, and there have been changes since. So spawner once configures the behavior of spawn reset. So spawn reset behaves slightly differently depending on how you configure how many times you want it to run. which is interesting. This will give me an error around ball radius. We're just going to make this like 20 at the moment because we don't really care. So our system is still running, but we aren't getting anything. Spawn color normal. Maybe we set the props because we're using the new code. Is it still valid to use insert for marker structs? It is, I believe, still valid, but if you're spawning, you don't need it anymore. So like, it used to be that dot insert was the right way to do it, and then everything got consolidated, but dot insert still works. So I was hoping that this would be a little bit normal dot normalize. Where's normal coming from? Normal's coming from up here. We don't need normal. So let's do like vec 3y and normalize it. Although I don't think we need to normalize the unit version of vec3y. You don't understand why Bevy is doing such major changes every update. It's because they aren't 1.0 yet. Bevy is not a 1.0 game engine, right? Like it hasn't been around for years and years and years and years. A lot of the other engines that you think of, like Godot and Unreal and Unity, have been around for a decade or more. So compared to them, Bevy is in like year 3 or 4, something like that. So that's why they're doing breaking changes now. Because typically, especially in the Rust ecosystem, once you hit 1.0, things tend to be significantly more stable. But Bevy is not 1.0 yet. And a game engine is a very large thing to build. Cannot assign float 4 to float 3. Did I get a float? Does this need to be a 4? I would have assumed it was going to tell me. Float 4 versus float 3 is typically something that is an issue with shaders, right? So in shaders, the data will go in and it'll be like a 4-dimensional vector. But I'm giving it a 3-dimensional right now with vec3y. I thought we were extending that with a 0, but maybe not. When they get to 1.0, people complain not a new stuff is coming. Yes, that is always the case. Hey, Pwn Rider, how's it going? There's always a group of people who wish changes were coming faster, and there's always a group of people who wish changes were coming slower. And balancing that is tough. This isn't supposed to be a vec2, right? It's a little awkward that this isn't typed. I don't love that. But shader stuff tends to not be typed. Okay, you can see particles. I don't know if you can see that on screen because they're literally, like, very literally individual pixels. I can't even point them out, but if I destroy enough of these, you should start seeing like things that look like little dead pixels if you're looking close enough. Um, very tiny particles. Are you using Yabai by any chance? I am using Yabai. Yabai is the window management system that I've been using for a few years now, actually. I love it. It's really good. I understand that not everybody will want to do the things that are necessary to run it, but it does everything I need it to do. I really love that, for example, when I'm doing streams or videos and I'm clicking back and forth here, Yabai has removed the shadows from these windows. So it doesn't look weird if I'm like clicked into VS Code and talking about the terminal. maybe add a shortcut to destroy all the meteors since I'm not great at the game currently. I could do that. Let's see. This is random colors. So why are these so small is the question currently. We've got the translation. It's got to be because I set the ball size up here, right? And I set that to something like 20, if I remember correctly. So what happens if we set this to like 200? Have I tried Raycast? I do not use Raycast. 200 doesn't affect the particles. Position, color, spawn color, update drag, lifetime, spawner. Okay, let's see. Set the position to be the collision point, which in this example is always the emitter position at the ball center, minus the ball radius alongside the collision normal. Also raise particle to z equals 0.2 so they appear above the normal background box. I feel like this is logic we don't need. But it is only adjusting the position, so I don't think it's a big deal. So I'm just going to leave it there. Yes, they were coming from the bottom of the screen. That is accurate. I think that this position logic right here, this like attribute modifier for the position, is not going to be relevant to us. Because I believe that the collision position that we get down here is the meteor position. So when we see destroyed at, we're not getting like where the laser hit the meteor, we're getting the meteor position. So if we go back to that, all of this position logic here that they're doing to like recenter it to get that particle to show in the right spot is not actually relevant. But that is not our issue currently. Spread 2, 1, speed, velocity. I do know that they set up their camera in a very specific way. So I think that they might have just zoomed in a ton. Fixed vertical 2, projection scale 1.2, Z projection. So they've done some modification around scaling here, which means that these numbers might be too small. So for the spread, let's up this quite a bit and see if that affects our particle. Does not. I'm reasonably happy with the lifetime. I think the lifetime of the particles is fine. Velocity, speed, initial velocity. Color, lifetime, age, position, size modifier. This is just going to make the particles very big, if I am reading this correctly. Maybe I do need that destroy all command. So you can see the particles coming in now. They aren't spreading out very much. They're just kind of like landing wherever. So if I destroy that, it's kind of like right at the bottom. They're individual particles, so that's why they're so small. I like them being small. We can make them a little bit bigger later. So position and velocity. I thought spread was going to do something for us. Where's spread used? Spread is used in velocity. Speed. I do think that it's basically just a scaling issue to finish out like the visibility of the particles. Yeah. So like you can see them starting to be a little bit better. I really do need that. I was like, no, I know I'm bad at the game, but it's fine. I'm significantly bad at the game though. Especially on stream when I'm trying to look at stuff. Okay. So you can see all of the little particles. They're spreading out a little bit more. That's great. So that's the speed. Spread. I don't think we want the normal in this calculation. So I'm going to remove it. But we do have particles spawning now, which is great. Okay, maybe we do need the normal. They're spawning in a straight line at that point. Tangent, vec z, cross, normal. Not really what I want. I don't think I want tangent or normal in here, honestly. And then I think I want the spread to calculate. Oop, that's wrong. What happened there? Let's do a cargo check. It is not something that happens until runtime. So this is a shader issue. Failed to build a valid module. Entry point at compute is invalid. Normalize. So Bevy Hanabi does use compute shaders. In our case, the spread looks like it's a scalar. The tangent is a vec3, which means the normal is also going to be a vec3. So this is trying to set the velocity to be a random direction, mostly along the collision normal. I don't really want the collision normal. This is logic specifically for the behavior of the 2D example that we were looking at earlier. So if you look at, or not the 2D, but the spawn on command, this one. This is the example that we're effectively latching onto for this logic. So what they're doing is they're taking the normal and they're kind of spraying the particles off the side of the box. And by doing so, they don't need to like cull anything that's outside of the box. So when we think about velocity, what do we actually want here? I think we just want it moving in a random direction. So this rider, rand, float. I think speed is really just what we want. And then spread. So at this point, it's basically just configuring the particles in the way that we want them to be configured. I think I'm okay with that being the success for the stream at the moment, because we've got particles spawning at the event locations. And then picking basically like the best way to make this show up is going to be a little bit of experimentation. But we do have the particles spawning at all of the locations that we need it to, which I'm very happy with, actually. I don't love the Bevy Hanabi API. There's a lot of like, I get that we're building up a dynamic expression here, right? I get that we are sort of inserting this into something that is going to run it and run it like at arbitrary times and arbitrary locations, but it's not the most intuitive. This has normal. So with name, spawn on command, with property, spawn color, with property, normal. A couple of initialization parameters. So the position, the velocity, how long it should live, the current age or the initial age, and the initial color. There's some drag here. And then a size set modifier. So it's 3 screen space size true. I don't know what this does. Let's check this out for a second. I don't know that that did anything. Set size modifier. Let's go check the docs. Set size modifier. So this is a size, which is a CPU value, and a screen space size. Is the particle in screen space logical pixel? If true, the size is in screen space logical pixels and not affected by the camera projection. If false, the particle size is in world units. Interesting. So what are we doing here? We're doing true by default, which makes it screen sized logical pixels. Okay. That explains why everything was so small. I'm viewing this on a 4K monitor right now. So if we're using screen size pixels, then a pixel on a 4K monitor is very, very, very small. And they did get slightly bigger when we did false here. I feel like false is, for this example, probably what we want. We want something that's fairly relative to the size of everything else, not necessarily like an intricate 3D like smoke system or something. So I think I'm going to leave this to false so that we get world space coordinates, which makes the sizing a little bit better or a little bit more intuitive. We spawn our particle effect bundle with the spawner and the effect properties. So this effect properties is why we weren't getting the query to land before when we were using the other example, which is this query. So we query for effect properties, effect spawner, and transform. We do an if let if the effect isn't ready. We never see this warning anymore, is something that I'll note. And I think we never see this warning because we're using events here and the example was not. So I don't think that, other than the let else for destructuring these properties, this warning is probably never going to fire. The effect that we're spawning, we spawn in at the meteor event. We're picking a random color. If you've never used Rand, this is Rand. It's a, you know, a pretty typical Rust crate. We're generating a U8, so a number between 0 and 256, which is actually going to be the 255. And then this is the hex encoding of a color. I don't like bit shifting, honestly. I find that especially teaching, most people haven't encountered or like internalized bit shifting. So like doing left shifts and stuff is not readable to a lot of people. So that's the spawn color. And that's how we get the spawn color in. So we're setting something that is a text name called spawn color. We're using the expression writer to get the prop that is spawn color. And then we're using that when we do the initialization color. So it's a little bit like convoluted. Like I kind of get why it exists like this, but it's definitely not straightforward. So then we're also setting the normal here. I think I'm going to get rid of this normal stuff. We don't really need it. We want everything to kind of like explode in all directions because it's like a meteor exploding, right? In this case, we extend vec2 to make it a vec3. And then we reset the particles. The reset function is also kind of weird because we're basically taking this spawner, right? Which if we look at the types up the top, it's an effect spawner. Effect spawner. And this is maintaining the state of the spawner for an effect. So I feel like it's unclear in the documentation, but what I believe is happening is we're creating a new spawner for every instance. And those spawners probably get reused. So like when one is done, we probably just get it from a pool of spawners. And that's why it's called reset and not something else. So there were two things that I was thinking about doing today. One of them was this particles, which we just did. I will turn the particles into a YouTube video. I have a little bit more research to do. I think that the explanations for things like reset are going to be very important. Otherwise, people aren't going to understand how this all works together. Also, the expression writer is very confusing if you're just looking at the docs, because it doesn't really like explain what that is. Like if you look at the README, it's not even in here. If you look at the docs, it's not in the front page. So like this expression writer is just kind of like hidden back behind a bunch of like modules. If you look at the examples, you'll see this, otherwise you won't. So to do a live system today would require collisions on the ship. Adding collisions to the ship should be fairly easy. It's the same thing as meteors, right? So switching gears a little bit for a second, let me add this. First particles implementation. And that's pushed up. Oh, that is not pushed up. Let me git pull rebase. And then I think there's some conflicts that will be here. We pulled the RNG generator out of the loop in a PR, so that's fine. So if you don't know what I'm doing, I'm rebasing, which is basically taking the things that I have and I merged a PR on GitHub, right? So there's code on GitHub that doesn't exist in my local, but I did a bunch of work local. So I'm doing a git rebase, and this UU tells me where that conflict is, which is the RNG stuff that we just looked at. So this RNG got pulled out of this for loop, and I wrote some code like right where that would have been. So there's a conflict. So after fixing that, I'm going to git add-u and git rebase continue, and it'll pop up this commit message that I just had for the last commit because we made some changes, and now I can push. Everything's fine. Mike, how's it going? Haven't seen you in a while. Glad you're enjoying it. So yeah, we just did particles for the asteroids. If we could do a life system or a lives system for the ships, the first thing we need to do is add a collider. So if we look at the meteors are how have like bundles. And in the meteor bundle, there's this collider. This collider comes from a package called Bevy XPBD2D. And it's specifically this collider. So it's really a physics library, except we're not using any of the physics at all. We're only using the colliders. And I did this because I wanted colliders that maybe looked more like the meteors. You can see we have some circles and stuff like that. I think the colliders built into Bevy right now are kind of not the best. So like AABB 2D just got added in the last release. You can use this to do like intersections because it implements this trait called bounding volume, right? And if we look at bounding volume, it has maybe it wasn't bounding volume. It was what was the other one called? This contains, I think it was a different trait that I was thinking of. Intersects volume. There we go. So there's this trait called intersects volume that this AABB2D implements, and you can pass it in a volume. Presumably there's going to be more volumes in the future. So we've got bounding circles, and we've got 2D and 3D AABB, which is axis aligned bounding boxes. Basically, those are squares or cubes. So we've got circles, spheres, squares, and cubes, but that wasn't necessarily going to fulfill everything that I wanted. So you can do intersects tests with those, but Bevy XPBD2D includes colliders, and colliders have, see if I can see the initializations for these somewhere. So it's got circle, ball, ellipse, rectangle, cuboid, round rectangles, half spaces, polylines, et cetera, et cetera. It's got way more options, basically. And more importantly, it has compound. So what we can do with Bevy XPBD2D is, I'll probably for today just do like a triangle for the ship. But what we can do is actually spawn a bunch of colliders and treat them as a single collider for the purpose of the ship, so we can better match the actual ship collision. I'm trying to keep things fairly simple for this so that the repo makes sense to people. So we need to do this collider. Once we do the collider, we may or may not need to modify the collision code for the meteors. So we've got these meteor destroyed events. These are being fired, if I remember correctly, from controls, which is a really silly place to put it, I know. But I wrote it on a plane, and I haven't refactored it yet. Lib. Start game. Yeah, laser meteor collision is in lib, which is like, I don't know that that's the right place for it. But again, I wrote most of this game on the plane. So meteors here and lasers, we're querying for all the colliding entities with a meteor, which takes those colliders automatically and fills out a hash map, basically from like entity to, or like maybe it's a hash set now that I think about it. It might just be the entities. But basically it fills out this hash set of like things that the meteor is currently colliding with. And then we're checking to see if the things it's colliding with are currently lasers. We could use something called collision layers for this to make it so that like meteors can't collide with meteors and lasers can only collide with meteors. But I haven't gotten that far yet. So when we add a collider to the ship, we're going to want the ship to be able to collide with meteors, but not with lasers. So we can keep doing it this way. We can basically do get the ship, get anything it's colliding with, get all the meteors, get all the lasers, like check to see if the meteors are in the colliding entities. If they are, then the ship like blows up and the particles happen. And if not, it's fine. And then the only other thing we need for a live system is a resource with the number of lives and an event for when the ship explodes to do the particle and then to also do a reduction on the life count. And then on top of that, we'll want to display lives somewhere, but we can do that whenever, really. So let's get started with wherever ship is or player. I spawn player somewhere. I think I spawned player in lib. So we've got this start game. Start game runs when we enter the playing state of our game. And then we've got player here. So based on the ship type, we're probably going to want different colliders. So we'll probably set it up like that. Where's ship? Ship is here. So we've got like player A, ship B, ship C, whatever. They use different indexes into our sprite sheet. That's the ship selection that we've seen before. So we could probably return a collider from this as well. So like pub fn collider returns a collider. And for now, let's just run like any collider. I don't have Bevy XPBD 2D in this, so let's do use Bevy XPBD. I'm really happy they're going to change the name, by the way. I don't know if you've noticed, but the amount of trouble I have saying Bevy XPBD 2D over and over and over is higher than I would like it to be. So we have a couple of options here. We could go with a polyline and literally draw the shapes out for the ships, which is probably something I'll do another time. We could do a capsule as something really basic, which will kind of look like a rounded rectangle. That's probably the best choice. We could also do a triangle. Most of these look like triangles, so it wouldn't be that bad. Triangles won't match exactly either, though. So maybe we'll try the capsule, and we'll make the capsule probably some arbitrary size. We can get that from the sprite sheet these days. Let's make it 20. Let's make the radius 10. So this is just going to be an arbitrary capsule size. In the future, we'll do a match and we'll do a different collider for each ship. But for now, we're just going to have this collider function on player ship type. So in lib.rs, when we spawn our player, we have the ship type. And something we want to do is ship type and call this collider function. I didn't make it public. I'm just realizing. So, oh, I did make it public. We're good. So this just returns us oh, it doesn't take self. That's why. Looking at this going, okay. So at some point we are going to use like the ship type, whatever the player's ship type is, whatever they've chosen. So we do need a reference to that ship type. Even though we're not currently using it, we will use it in the future. At which point we can do ship type.collider. That gives us this collider component. I believe I still have the debug for the colliders on. So we should just see, yeah, so we see a little orange kind of like circle here. It's not quite the right size. So let's make some small modifications to that for a second. We'll double the size vertically and then leave the size horizontally. So it'll really just be like this center area that can collide and the wings won't collide. But I think that's fine, honestly. This is just kind of like getting started. We need the collision to happen before we need the collision to be perfect. So now we've got something a little bit bigger. We could probably make it even closer, but that's fine. I think that this won't trigger anything. So currently we are not triggering anything by kind of like colliding with, and you can see the ship under the meteor here with the little capsule. So we aren't colliding yet, and we need to collide. So similarly to the way that we're doing the laser meteor collision, we're probably going to do basically the same thing for the ship collision. So let's do ship meteor collision. And we'll change this query to be ship, which is just going to be a query for the player entity. Actually, now that I think about it, what I'm going to do is I'm going to make the ship query this one, and this is going to be meteors. So this will be with meteor. So we're getting all of the entities that are meteors, and we're getting the ship, which will be the player. And we're getting the entity for that. Anything that's colliding with it, meteor type is not valid, and the transform is. So we need to get rid of meteor type there. We will only ever have, let's call this player ship, actually. I'm gonna call this player ship. So we're only ever gonna have one player ship, right? But I'm still gonna loop over this because in the future, we could have multiple players. This could become a multiplayer game. I could add networking. And at that point, it's really annoying to go back and just be like, change everything, right? When this is such a generic function. Again, I like not panicking in Bevy games and warning instead. So if I wanted to, I could do like player ship dot get single, right? And this returns a result. And if that is not what we think it is, we can warn and return here. I'm really growing on that pattern because it makes refactoring easier. So let's see, player ship, for every player ship, if colliding empty entities is not empty, so that is basically our hash set. We'll call this entity meteor. And this is going to be meteors. So we're just going to iterate over all of the meteors. If colliding entities contains a meteor, we don't need to despawn the meteor. We do need to despawn the player. So where's our player ship? This is called entity meteor. This is player, destroyed type. This is not going to be a meteor destroyed event. I'm going to comment this out for a second. This is going to be where we to do send ship destroyed event. I don't know that this actually needs to be an event, but I think I'm going to make it an event anyway. So ship meteor collision, not a system that's running, which is why it's highlighted in yellow right now. We haven't added it to our game. So we've got the player entity, the things that are colliding with the player, the transform, which is where the player is in space right now, and then as long as colliding entities, so things that are colliding with the player, is not empty, we iterate over meteors to see if we've hit a meteor. If we did hit a meteor, we need to despawn the player. We do need to respawn the player later, which I think will happen in this event. But that's where we're going to start. So I think this will work just off the bat. Where is our plugin? This is just lib.rs, isn't it? This is the problem with putting things in lib, is then you need to come into main. Paste this here. We'll run this on the same. Actually, if we're going to run this on the same restrictions, I'm going to make this a tuple and then put the restriction on the tuple. We do have to bring this in from our lib. There's something wrong there, so let's see what the compiler says. Player is private. Interesting. Where's player? There's player. We can make that pub. It is not an issue for us. So where was main? So because systems accept like this wow, I just blanked on the name. Dependency injection, right? You write your system so that it queries for whatever it needs. That uses, you know, the system param trait or whatever. But they end up being like literal arguments to functions, right? Like this is just a function you could call if you had these things to call it. So if you have like player here, then that is just a thing that somebody needs to be able to pass in, which is why it would need to be public. So let's try to hit the asteroid. So the player is gone, which is great. That's what we needed. One of our other systems is expecting a player component and didn't see one, so it is spitting out an error. But we have our collision working. You want to watch my Rust tutorial. I don't know which Rust tutorial you're talking about. What window manager is that? This is Yabai. Yabai is amazing. That is also not how you say Yabai. I don't know how to say Yabai. It is, I believe, a Japanese word, if I remember correctly. But this is the tiling window manager that I use. And I use it specifically for that binary space partitioning layout that you're seeing on screen, which is absolutely wonderful. Cannot recommend it enough. It is not necessarily for everybody. The development is, I wouldn't say the development is slow, right? But it can lag behind a little bit. So if you do care about having this active, you might want to not like upgrade to the very latest beta Apple OS release, you know, because this is somebody's side project. It is not, you know, a commercially supported piece of software. So like support happens when it happens. It has happened for the last few major versions of Mac OS. But keep in mind, you do need to do certain things to your system, like this system integrity protection stuff, which is optional, but some features require it. And then it will prevent you from being like on the latest beta. Good morning. How are you, Rock? Oh, I didn't even realize you were on a Mac. Yeah, this is a Mac. This is an Apple system. I like Macs for the amount of software I get to run. Like I do things like Photoshop and DaVinci and all of these other things as well. Obviously, I make videos. We're on my YouTube channel. So having all of that stuff available is really nice. Okay, so we have our ship despawning. This is not going to be meteor destroyed anymore. This is going to be ship destroyed, right? What do we need to send in ship destroyed? We haven't created this event yet. We're going to send it here. I want to send the transform because I want to know where the user like sort of got their ship hit. I think in the future, one of the things that I really want to do is have the player's ship kind of spawn in eased from wherever it was to like the middle of the screen. So I want to keep the transform around. I don't think it matters what meteor hit our ship, so I'm not too concerned about that. Just got done watching a demo from Steve in 2016 showing Ruby alongside Rust. Feels like forever ago. Yeah, 2016 was so long ago. Wow. I mean, realistically, it's almost a decade, right? Like 2 more years than a decade. So it is a really long time ago. So we have these events, this ship destroyed event. I think we only need the transform. We are going to have to respawn the ship. I think the only place we're respawning the ship right now is in main. Or maybe it's in lib start game is what it is. So it's in the same file. I'm doing this pretty ad hoc though. So like all of the stuff that you require for a ship to be able to actually function in the world is encapsulated right here. So maybe we pull this out into a ship bundle. Make that a little bit more specific if we're going to start spawning the ship in multiple places. This is functioning off a choose ship event. So maybe we do need to pass currently the ship type. So do we have the ship type here? No, we're not even querying for it. So let's do player ship type, right? It needs to be a shared reference. And then this will be ship type. So we know which ship to spawn. I'm not keeping that in a resource right now. I was keeping it in a resource at one point. I'm not too concerned about it though. Passing it around with this event is fine as well. Okay, so that's that. We do need to create this event. I think the meteors file has the other event. Yeah, so here's the other event for meteors, and then we need to add that. Wow, I have a lot of code in this meteors file. I didn't realize that. We have to add that to the plugin somehow. We do have a ship file, right? But we don't have a ship like plugin. So maybe we do that too. Struct ship plugin, impl plugin for ship plugin. This is coming up at some point. Let's get that out. Let Rust Analyzer implement this for us and then do dot event. This is not meteor destroyed. This is going to be ship destroyed. So this is just going to be a plugin that's responsible for like random ship stuff, right? In this case, we're going to add the ship destroyed event so that it can be fired and listened to by other plugins. And then this is our ship destroyed. So transform and player ship type. Nope, not playback settings. Player ship type. Yeah, so destroyed at destroyed type. That's fine. This is going to be ship destroyed. We do need to add that plugin in now. We need to import the plugin first. Or not the plugin, but the event. And then this probably needs... I don't think we can use the shorthand here. I think this needs to be dereferenced. But... Oh, right, because I didn't put ship type in here yet. So we got ship destroyed. There's still something wrong with that. We're going to add the plugin before we deal with it, though. Oh, Argus is still running. Dang. So if you didn't see Argus, Argus is a kind of like trait debugging tool. I haven't seen it pop up anything yet. I didn't realize I even had it still running after I made the last This Week in Bevy video. Struct ship destroyed has no field name ship type. That's because it doesn't. You're absolutely right, Argus. I don't want that popping up all the time, but let's call this ship type actually in the event itself. I think that makes more sense. I don't know what the issue is there, so let's see. Move occurs because whatever. Yeah, that's fine. We're just going to clone this. So we're cloning the ship type in. It doesn't really matter. I like having my structs own data, especially in Bevy, where they're just going to kind of live forever. I was not aware of Argus. Thank you. Yeah, Argus is very cool. It's experimental software, right? So it came out last week, something like that. Like you see it has 50 installs. Like nobody's using it yet, really. But the idea here is that when you make mistakes, you should be able to open Argus. So let's see. We haven't added the plugin yet, but let's say I took away player ship type here. And then I opened Argus and I asked it to inspect the workspace. We get this thing on the right here that has start game, laser meteor collision, ship meteor collision. Ship meteor collision clearly has an issue. So let's open that. Player ship, meteors 4, whatever. If we open player ship, we see a bunch of X's. This starts telling us like what is the actual problem, right? And it does take some knowledge about like the traits and how they work inside of Bevy. So it's not really a beginner tool in the sense that it's going to be super helpful if you don't already know what you're doing. But if you do know what you're doing, if you do know what some of these traits are, you can see, for example, player ship type doesn't implement query data. And you can keep digging into this and kind of try to figure out why and whatnot. But the reason in this case is because it's not a shared reference. And then once it is, Argus is fine. And it collides with Rust Analyzer. So I have noticed that you get a lot of like squiggly red lines down here, even though this code is valid. If we leave the file and come back, like that squiggly red line goes away. But it's basically like Argus and Rust Analyzer don't play well together currently. Are you making your own particles or using a plugin for them? I'm using Bevy Hanabi. Bevy Hanabi is a wonderful GPU-based particle plugin. I don't love the API, but I do understand why the API exists as it does. So if you're willing to kind of like read the examples and whatnot, Bevy Hanabi is quite a powerful plugin for doing GPU-based particles. There's a couple of other plugins as well that do CPU-based particles, but I'm kind of less interested in those. Yeah. So there's other CPU-based particle systems on This Week in Bevy, for sure. Let's see. We've got a couple particle systems this time around, right? So that one's using Bevy Hanabi. This is a custom. I think that's a Discord link, so I'm not going to click that. Inoki. There we go. So Bevy Inoki is one of the recent ones. There's a couple other ones. This one is specifically created so that particles work well in WebGL2. For this Asteroids implementation, don't care about legacy support for technologies that are kind of like supposed to go away, because I'm not really taking Asteroids and like shipping it to a bunch of people for WebGL. But if you did care about that, if you cared about the maximum browser support, for example, WebGL is far more supported than WebGPU at the moment. So you could use something like this. And it has a slightly different API. You can see like this uses RON files to define the effects. And there's a particle spawner bundle with the ability to define materials for it, or custom materials for each of the particles. Very cool, very like active space. There's a couple different particle plugins. Bevy Hanabi is the one that I keep going back to, because I like the idea of having everything on the GPU. Okay, so we need to add this plugin. What did I call it? Ship plugin? Nope. Did I not make it public? I did not make it public. Yeah, I think it all depends on like what you want to do with your game, how you want to ship it, where you want to go with it. For me, this Asteroids implementation is kind of like a thing that I'm creating so that other people can see how to create games with Bevy specifically. So, you know, Bevy Hanabi has been around. It's maintained. I know it will be maintained to the next version of Bevy. I don't know that for some of the other plugins necessarily. They haven't existed as long. So that's kind of like impacting my choices here. Not that the other plugins are like definitely going to, you know, die out or whatever, but Bevy Hanabi is repeatedly updated to every major version of Bevy for a number of versions now. Okay, so that's the plugin. We have the event firing. We aren't listening to the event yet. So really all we're doing here is checking to make sure that the game kind of still works. And if you spawn on an asteroid, then the ship goes away. So that's good. Keep these streams up. Literally just randomly found you via Twitter yesterday. That's interesting because I don't really use Twitter anymore. I have my account still, and I still kind of see notifications and stuff if you tag me or whatnot. And I interact with those, but I don't really tweet anymore. I kind of spend my time on Mastodon and making videos and things like that. But yeah, I'm thinking about doing this. I don't know if I'm going to do it Saturday mornings or Friday mornings, but later in the week is my intention. And it gives me a little bit of time to kind of like build out some more games and things like that. I want to put a game on Steam this year. That has been a kind of like a constant goal that I've been kind of failing at for a while now. So I want to make sure that I can get something onto Steam. I'm not looking to make like the next Hollow Knight or anything. I just want to ship something. There's very few good Rust streamers. Well, there's very few streamers in general. So I also don't really consider myself like a streamer, if that makes sense. I'm more of a video creator, right? Like I think of myself more as a YouTuber than a streamer, if that makes sense. So like my primary output is things like This Week in Bevy or Rust Adventure, which has a bunch of Rust educational videos, or the YouTube channel, which has a bunch of, you know, like Rust videos on it. Streaming is kind of just like an add-on, something that I kind of like to do for fun every once in a while. Okay, so we've got the plugin, we've got the event, ship event. We're sending the event. Now we need to read the event. So in Meteors, that's where we're doing the read event for the other stuff. Do we do the same thing? This is our event handler. Probably, right? Like it's probably almost the exactly same like logic even. So image assets, of course. This is not going to be meteor destroyed. It's going to be ship destroyed, not shop, ship. Kenny Sprite Sheet Assets is an asset loader that I talked about in a video that went out this week on Tuesday. Bevy Hanabi Prelude needs to come in. Of course, I didn't select the thing. Prelude star. Yada, yada, yada. I don't think we need to care about window because we aren't doing wrapping particles. So we can get rid of that. We don't need that ball anymore. Actually, let's keep the ball just in case these particle colliders collide for some reason. So we've got our effect. I think we can use the same effect. So I'm not too concerned about it. The space sheet. I should rename this. This is also not the right name anymore for this system in the Meteor. Player, ship, destroyed, event handler. So we need the sprite sheet available. The RNG. We can keep the RNG just to be like, okay, maybe we don't spawn exactly in the middle. We're probably going to have to do something like insert a timer, if that makes sense, at some point. So what's going to happen here is I'm going to spawn us in 0, 0 to start. So the ship is going to spawn in 0, 0. If there's a meteor there, we are going to die immediately. That is not going to be fun for a user or a player. So we are going to have to do something to deal with that later. I'm not going to deal with that right now. It's just going to be super unfortunate for the person playing. But basically, we're going to have to insert some kind of timer or a resource or something to be like, hey, we want to respawn. And then we'll have a different system that's responsible for like respawning when it's safe. Ship destroyed. So ship destroyed. This creates the particles. I think all of this is going to be fine. Destroyed type. So this is ship type, right? But that doesn't really matter for us. And we're really just going to spawn here. And that ship type is going to be responsible for what ship type gets spawned, but not much else. So we're going to stick a to-do here, spawn ship. In lib, we have our ship spawning code, right? Like, so this is our ship spawning code. We have options here. We're going to make a ship bundle, which is going to require some of these other things to be set. We can also create a function to construct this set of stuff. But either way, we need all of this stuff in ship. And we probably do need a ship bundle. So let's do derive bundle. And this is going to be pub struct ship bundle. And then all of these things are what we need. So we're just going to get rid of the actual values. And this is going to be, we'll call this sprite bundle. Just get rid of all of it, basically. Naming things very straightforwardly, more than anything else. There's no reason to be like fancy here. And it'll help to know, like, when it's a collider, it's a capital C collider, etc. So if I get my commas correctly, all of that should work. Create player, wrapping movement. Some of these are just marker components. So now we have a ship bundle. That doesn't super help us out though, because we still need to specify all of this data, right? Sprite bundle still needs to be specified specifically. Texture Atlas does, etc. So we have a couple of options. I think we're going to take the lightweight option. What I'm going to do is basically replace this with a ship bundle. And let me do this outside. I don't think that I actually fill struct fields. There we go. So in this case, I'm just going to take all of these and put them into the right spot. And then this is going to be the thing that we spawn. And this is going to be, all of this red here is going to be because of the fact that those fields aren't public. So if I run this, you can see private field, private field, private field. So all of these, if we're going to be able to set them externally, are going to be public. Now, there's no real reason for like player and wrapping movement to be public. It's also worth noting that we could register default implementation for this bundle. So we could impl default for ship bundle, and then we could use that. We do need to set some things. So we could use a function that then returns like a ship bundle, for example. But I think just having the ship bundle is enough for me for now. So instead of doing anything fancy, I'm going to take this ship bundle, which now we have encoded into the type system that a ship requires certain components. And I'm comfortable with that being like the total like situation here. So this is going to be ship destroyed. Ship destroyed gets us destroyed at. This transform is going to be like a 0-0 transform. So when our ship gets destroyed now, assuming that I added this system, I forget if I added that system or not. Assuming I added that system, like we should be able to drive the ship in. We aren't, I didn't add the system. So when we do these collisions, let's see, Meteors has something similar, right? So if we go up to the Meteor system, it's going to be like this. And it's going to be player ship instead of sandbox Meteor. So I'm just going to take this and I'm going to copy it into ship and put it here. And this is going to be player ship destroyed event handler. And we need to bring in some of these resources. It's worth noting that these plugins are not like externally usable plugins. So I'm fine with just like importing the pause state here or importing like the game state here. If this was a plugin that was usable by somebody else, like a third party who might have wanted a different game state or a different pause state or something like that, then we would be configuring this with a resource or something like that. Or ship plugin would have some fields on it here to define those things. But because this is just a way to organize my own code, we can be a little bit more cheaty and we can just import pausable. Okay, so player ship destroyed event handler should be running. Where it's running in post update because the system that sends the events is running in update. So we want to receive these in the same frame. So that works, right? I think this will just keep working, right? So every time we hit this meteor, or really any meteor, we respawn. Make sure that when we shoot, it doesn't. So it's respawning immediately. There's no animation. There's no warning for the player, hey, you're about to, respawn. It's also retaining the momentum, which is a really interesting phenomenon. So if we look at when we spawned our ship bundle here, right? We're spawning it with a transform, a texture atlas, player, ship type, collider, wrapping movement. We're kind of despawning this and then respawning it. And then I think controls is where our ship movement is. If we want that ship to stop moving, which we probably do, we probably want to reset this movement factor. So the input actually is something that I should do probably in a different stream. I want to move to Leafwing, clean up this input system quite a bit. But this movement factor resource is just something that I created. So it spawns at vec2. So let's grab the movement factor here. And let's go into ship. And let's say ship movement, right? So res mute movement factor, which we need to import here. Oh, is that not public? Might not be public. It's not really something that I'm supposed to be handling outside of this file, but for the moment, like sometimes you just get things to work and then you refactor later. And I think that's just perfectly fine. So we're going to spawn the ship here. The thing we want to do is ship movement is vec2 0. That is giving us an error because it needs to be wrapped. Oop, that's not the right key to hit. I don't have mutable. That's why. So to mutate something, you must declare it as mutable. This is Rust after all. So ship movement.0 equals vec2 0. Now our ship, when it explodes, should not move or should not retain the momentum. So it just stops now. Which is probably significantly better. But I'm generally happy with that. Loving the stream, Chris. Thanks for all the Bevy content. Yeah, thanks for watching it. I appreciate all of y'all, hanging out, giving comments, watching the videos. Really makes it, more rewarding for me when I put stuff out to have people actually enjoy it and find it useful. Cool. So that's all happening. So our ship can collide with a meteor and it gets destroyed and respawns in the middle of the map. That is wonderful. It's great. It's everything we wanted it to be. There is a second part to this, which is basically how do we keep track of the number of lives like the player has? So maybe we do like a lives submodule. Create that file. Let's do use Bevy prelude star. I'm going to struct life plugin. I don't know that we actually need this. We do need to initialize the resource. So I think that's going to be fine. Life plugin or implement plugin for life plugin, and then let Rust Analyzer write that type signature for us. I really don't like writing like this line right here. I let Rust Analyzer write that for me all the time. Like whenever I get the opportunity, if I'm implementing a trait, I let Rust Analyzer write that function for me because it's just busy work. So we're going to do app.init or I guess insert resource, right? And then we'll have a resource down here that we derive resource on, struct lives. We're not going to do like a health system. We're just going to do a lives system. So I think this is just going to be like a U size theoretically. Like it could be lower than that, but let's do lives 0, right? So now we have, well, actually, we need lives 3. We need to have some lives, a number of lives. I don't know that. I'm trying to think about how I want to do this because we have a resource here, right? And what we could do is we could go to our ship destroyed event. And this is probably the easiest way to do this, honestly, right? Mute lives, res mute lives, right? Import this. I didn't make it public, so I can't do that yet. But then we go down here and we say, oh, we're about to respawn, you know, lives minus minus, or like lives minus equals 1, like something like that, right? And then we can listen and run a system whenever the lives resource changes. But that sounds to me increasingly like an event. I think I'll go with the resource-based approach for the moment because it's just a little bit simpler. But that's the kind of trade-off in my head right now, right? Like we've got lives. We really don't care about how many lives there are, right? And we don't really, actually, now that I think about it, and I'm going to say this out loud, we don't really want to think about how many lives we have here, right? We don't care. What we care about is the fact that we are telling let's see, life events. What we care about is that this system has the ability to say you lost a life, right? Or your ship got destroyed or something like that. We don't really care about anything else in this system. So it makes sense that this would be an event writer and not a resource, even though we can react to resources. Now we don't have the life event yet. So one of the things we're going to have to do is life events.send life event remove. I don't know what to call this. Can always not live event, life event. Can always change it later. Never too worried about pub enum life event remove, right? So theoretically, this life event, we could do add, remove, we could do whatever we want. I don't think we'll be doing power-ups in this version of Asteroids, so I think actually remove is going to be the only one that we have. So in that case, this can be a struct because it's basically just going to be a marker struct, right? Add event, remove life event, and then this is going to be a remove life event, and this is going to be a remove life event. And we do need to import that. So now whenever we're about to spawn, we spawn or we send off a remove life event. There's something wrong with the system unless Argus is acting up again. Argus is acting up again. Okay. Okay, so now we're here, right? And we need a system that reads life events. So event reader, remove life event. We still have this resource, right? So for event in life events, which is going to have to be a shared reference. Actually, this is going to be .read now that I think about it. So this is going to have to be mutable. So event readers in Bevy allow you to call this function called read. And read, if we go look at the documentation, actually does, there we go, event reader read. Actually iterates over the event reader, anything that we haven't seen yet, anything that we haven't processed. So internally, this updates the event reader's like event counter. What it means is that when we read stuff, subsequent systems or subsequent attempts to read events won't get the ones that we've already processed. So when I call read here, we're just kind of consuming them. So for event, we don't care about this event in general. We probably also want this lives resource as mutable. Then for event in, we do probably lives .0 dot checked subtraction 1. I'm trying to think about what I want to handle here. So checked subtraction is going to let us subtract 1, subtract 1, subtract 1. Eventually it will hit 0. And we want to know when it hits 0 because then you're at 0 lives, right? You have no more to play. So we're going to need to do something if we hit 0. But otherwise, I think we're fine. So I guess if let, I think it's an option. Let me check that. Use size checked sub. It is an option. So you either get some with the number that you got back, or none. So I think we match here, actually. So match on this checked subtraction. Fill match arms with Rust Analyzer. This is new lives. Lives equals new lives. And then this is just going to set that. And for none, let's just error game over. And we'll just kind of handle that later. I'm not really too concerned about it at the moment. Run if in state game state playing, right? Is that enough parentheses? Bring game state in, add systems, not system. Okay, so what should happen is we should get a warning in the console now if we run into enough asteroids. So let's do this and make the console a little bigger for everybody to see. Or everything is going to crash because I did something wrong. Resource requested. Oh, I didn't add it, did I? Add event. Remove life event. I didn't add the plugin. That's the the one downside of using plugins for everything is I definitely forget to do that. Cool. So we have our thing running now. Oop, that was weird. Let me get that to work. Okay. So we've got our ship, and then crash 1, crash 2, crash 3, game over. So actually what that should be is the life count is number 2. But that should be game over for us. And then we, you know, transition to, you know, the game over state or something like that. Yeah, I think I'm happy with that for today. I think the live system is now like kind of working. We don't have any display for it. I want to put some hearts on the screen at some point. That's going to be reasonably simple, but I think I'll leave that for the next stream. So let's get this committed. Basic life system. So that should be up on GitHub now for anybody that wants it. It is under Rust Adventure. So it's github.com/rustadventure/asteroids. This is all of the code we just wrote on stream. If you have any questions or issues or whatever, feel free to file something. I think I can just drop this in. Well, I can't drop this in chat because I'm on the wrong computer. Rust Adventure, Asteroids. Okay, that should work. So that's the repo. That's all the code we wrote on stream today. I am going to call the stream there. I think this was a super successful like first test stream. I'm planning to do these more in the future. So kind of like either like a Friday morning or a Saturday morning like we are today. But yeah, this was mostly a test. And thanks everyone for hanging out. And I will catch you in the next one. See you Monday for This Week in Bevy.